Hey mathematicians, welcome to the Unit 6 Lesson 7 vocabulary video. For this lesson, we are going to be specifically discussing parallelograms. So we are going to talk about some of the terms and theorems that are needed for proving different aspects of parallelograms. So first up in our definition is just defining the difference between quadrilateral and parallelogram, okay? Quadrilateral is a four-sided shape, any four-sided shape. Quad meaning four, right? Four-sided polygon that we are working with here, where a parallelogram is specifically a four-sided shape whose opposite sides are parallel, okay? And this is something that we're going to go into depth of proving. You can kind of see in the hierarchy of quadrilaterals here, right? We've got quadrilaterals up at the top, and parallelograms are a more specific version of that. Up next, we have some more shapes that we want to make sure that you understand what they are and how they differ, right? So under this quadrilateral kind of umbrella that we've got here, you notice that parallelograms are under this trapezoid portion. However, a kite is also a four-sided shape, but it has two pairs of congruent adjacent sides. So you can see here, the red sides are adjacent and they're congruent, and the blue sides are adjacent and congruent, okay? Rectangles are four-sided shapes where all four angles are right angles and opposite sides are parallel and congruent. We have that 90-degree stipulation, so they have to be kind of congruent, the opposite sides. And then a square is an even more specific version of a rectangle in which all four sides are equal and all four angles are right. They're all 90 degrees. So it's kind of this hierarchy of shapes that we have going here under the term quadrilateral. Specifically, though, for this unit, we're going to be mostly talking about parallelograms. Up next, we want to talk about bisects and diagonals, or bisectors and diagonals. So for something to bisect a line, it means that it splits it into two congruent parts. The word bisect is something that we've used a lot, right? We've used angle bisectors, segment bisectors, but to bisect is to divide into two parts. We're going to be talking about bisecting diagonals. So a diagonal is basically a line that goes from one vertex to an opposite vertex. Okay, so we're going to be talking about how these lines bisect each other, or whether or not, I guess, these line segments bisect each other in the lesson. And then, yeah, if they are bisectors, if they do bisect each other, then that means that they're going to be congruent. They're going to be the exact same size. So if it is true that these line segments, these diagonals bisect each other, then that means that they are going to be congruent on either side. They're the same size because they split directly into two. Up next, the corresponding angle postulate. We've talked about this a few times. Remember, corresponding angles are angles that sit on the same side of a transversal. However, when we draw our little our box that goes around our vertices, right, corresponding angles are on the same side and they're in that same quadrant of our vertex. And the postulate, the corresponding angle postulate, tells us if we have two parallel lines and they're crossed by a transversal, that the corresponding angles are congruent. Okay, so that's what corresponding angles are, and the postulate that tells us that they are congruent. Alternate interior angles. Remember, an alternate interior angle is an angle that falls in the inside of our sandwich here. And alternate meaning they're on opposite sides of the transversal. And we can also state that these are congruent by the alternate interior angle theorem. If we have parallel lines that are crossed by a transversal, the alternate interior angles are congruent. Now, something that we want to make sure that we understand, because we're going to need this when we're talking about parallelograms, is what is the word supplementary? Remember, supplementary means that the pair of angles add up to 180 degrees, and specifically linear pairs are supplementary. Linear pairs are two angles that share a line or create a straight line. So these are our linear pairs here. And the straight angle is that angle that is created on a straight line that is 180 degrees. So just keep these in mind that these three vocabulary words are very intertwined with each other. The reflexive property is not going away. You're going to hear me talk about it a million times. Make sure you understand what it is. Remember that angles, line segments, symmetric figures are congruent to their, themselves. So AC is congruent to AC in this case, right? If we were to draw, I don't know, any triangle, I guess it's kind of the same thing, right? We're using the same line. The same line is in both of these triangles, so they're congruent to each other. CP-CTC theorem is also another theorem that's not going away. Remember that corresponding parts to congruent triangles are congruent. Our blue angles here are corresponding. I'm telling you that these angles are congruent. That means that these corresponding parts are also congruent. When we are working with our parallelograms and we're proving that sides and angles are congruent and all of these things, we are using the angle side angle congruence theorem to create triangles in our parallelogram, show that those triangles are congruent, and then we can show parts are congruent. That is why it's so important that we understand our congruence theorems. They too are also not going away, and the angle side angle congruence theorem is one that we will be using in this unit. Remember that they have to be back to back to back in order for us to use them. That is it for our video on this lesson's vocabulary terms. Please remember to always reach out if you have any questions, and until next time.